Good. Now we're recording. Let's see if we can write non-symmetrically. And we can. Wonderful. Okay, permutations now. So, before we start, we have to distinguish between two words in English which actually sound very similar. Well, not that they sound very similar, but people use them in a similar way, but they're slightly different meanings. So, the first one you have is permutation, and the second word is combination. The English here might be a little bit confusing because it's maybe not what you expect. So, both of these things represent lists. Okay, so they're both lists. Really, the only difference between the two of them is in one list you care about the order, and in the other list you don't care about the order. So, which one is it that you think you care about the order? So it's the list where the order matters. And what I mean by that is ABC and ACB, you would say they're two different lists then. So which one is that one where you care about the order, do you think? I kind of heard both. Yeah, permutation is a ordered list of items. And then the combination is unordered. Unordered, a list of items. So what I mean when I say unordered is that it's a little bit like a set, that you don't care, you don't distinguish between two that have the same members but are maybe written in a different order. So let's have a look at some examples. The key thing here is the one where you care about the order is the permutation, and the one where you don't is the combination. So let's have a look at some examples. Yeah, that's a good one. Shopping list. What one would that be? Combination, yeah. And like you said then, a password would be permutation then. Good. What about a class list? Combination, yeah. League table. Very much care about the order, yes. Yeah, a table. That one is like a league table. Permutation then. Yeah. And maybe one more, huh? Yeah, like a ranking list, like a league table. What else could we have? How about oh, I don't know. Something. Recipes and ingredients in a recipe or something like that. What do we think? Ingredients in a recipe? Combination. It's like the shopping list again, isn't it? So, anyways, the one thing you'll need to know in the questions, like in the exam, is recognizing which the two problems that you have. One where you care about the order, and one where you don't care about the order. So let's see how we can calculate here. Can I scroll down? Yeah. So let's just take a small example. Let's say you have a list of 3 books. So maybe that's A, B, and C. And perhaps in the story, you're going somewhere and you need to take 2 books with you. So you take 2 books. So I want to give you just 1 minute to list out, I don't know if you remember this vocabulary, the sample space. Do you remember that? Yeah. So just take a minute, 1 minute, just to write out the sample space here. So here you have, you could take A and B, A and C, and B and C then. Okay, that's simple. So let's make it a little bit harder now. So what type of problem is that? Combination then. Okay, so now let's look at permutations. So we'll take the same situation again. You have 3 books sitting on the shelf. And you actually do care about the order here because, you know, you would like to know where your books are. So it does matter to you which order they are in on the shelf. So this time, I want you to make the sample space for all 3. So I have the first one done already. You can stack the books as just A, B, and then C. So I want you to see all the sample space here. If you could write all the possibilities out here. So I've done the first one, A, B, C. Yeah? Yeah, did you list them all out though? Yeah. You got that? Yeah. So there's 6. The next one is ACB, BAC, BCA, CAB, and CBA then. There's 6 possibilities. Okay? They sometimes ask you to write out the sample space in the exam, but often what's most important is calculating this answer here, that you had 6 possibilities. So the way we can calculate that, if you think about it, oh sorry, can I scroll down? Yeah. So you have 3 positions to fill on your shelf. In the first one you can put 3 possibilities. You can either put book A, B, or C. In the second one you have how many possibilities? 2. You can't use the book that you put into the first slot. And the last one? 1. Now, the way the possibilities combine is with multiplying. You know, if you have 2 possibilities followed by 2 possibilities, you can go first choice, first choice, first choice, second, second choice, first, and second, second. So the probabilities multiply as you move across. Not the possibilities multiply. So this gives us a reminder of something we did in semester 1. Does this remind you of any calculation you have in semester 1? Factorial, yeah. You can make use of factorial for this. So do you remember n factorial? It's multiplying down. So for example, 3 factorial is 3, 2, 1, which is 6. So you could have jumped to the answer at the start. So a list of n different items can be arranged in n factorial ways. Now that actually word different is important here. We'll see that now in the next example. So just make note of that. We'll have a look at another example. Okay, you got that? Yeah? I can scroll down? Okay. Was that a no? Yeah? Yeah? Scrolling down? Yeah? Okay. Right. So let me give you another one, very, very similar to the last one. So this time, there's 4 books. But slight complication is, we'll say 2 of the books are the same. So you can't tell the difference between these 2 books. You have 2 copies of the same book. So A, B, C. Unfortunately, it's not much harder, but not quite as easy. You can't just say there's 4 factorial here, because we're complicated by the fact that 2 of the books are the same, okay? And to see what the answer might be, what the formula might be, again, I want you to write out the sample space here. But you won't have as many as 24 possibilities. Huh? Again, we care about the order, so it's a permutation, yeah. You got it? How many possible? How big is your sample space, Mubarak? I don't think so. 9? Well, no, I wouldn't say way more. I thought more than 9. Getting closer. No, are we just guessing now, or are we? You have 10 possibilities there. You got 10 as well? Okay.
Actually, 11. Yeah, 11.
Nobody's, yeah, okay. I thought the answer might be 12, so nobody I heard say 12. So let's have a look. So look, the way we'll do this to make it a little bit easier is for the moment, we'll distinguish between the A's. We'll say A1 and A2, but in the end, we'll then delete the possibilities where they look the same. But just for the moment, we'll distinguish between A1 and A2. Okay? So let's see. We have A1, A2, BC. A1, A2, CB. Okay. A1 and then B, A2C. A1, B, CB. What's wrong? I never said that. Did I? No. I think you imagined that. I've lost my train of thought. Where was I? A1, A2, BC, A1, A2, CB, A1, B, A2C, A1, B. See what he did. A1, B, C, A2, and then A1, C, A2, B, A1, C, BA2. Yeah? And then we repeat again. How many have I got there? 1, 2, 3, 4, 5, 6. Okay. So it's going to be the same, except the next one will say starts with A2. And then we still have to consider starting at B. And then the last one we have to start at C. The final answer is 12. That's what I said. Yes, yes. If you could distinguish between the A's, how many possibilities would you have? You would have 24, wouldn't you? 4 factorial. But we can't distinguish between the A's. So that means, you see this guy here, A2, A1, BC. We would consider them to be the same. So we don't count the second one. So when you actually run through the entire process, you'll see that you're only left with 12 of them, which you can tell the difference between. So I wonder if anybody can spot perhaps a quick way to get to that answer 12 without having to write this out and then count which ones you can distinguish. So for example here, this one is unique, These are all unique, aren't they? The 4 factorial divided by 2, but why divide by 2? And suppose there was 3 letters, A, 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 B, C. No, no. So you've got... Yeah, A, 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 B, C. No, no, not that. Yes, over 6. Because what you're doing is you're not dividing by 2, you're dividing by how many ways you can rearrange these 2. You see, you could swap A1 and A2 and you can't distinguish. Imagine you had 3 of them, A, B, C. How many different ways can you rearrange these 3? 6, and you can't distinguish between them. So this example kind of gives us the next rule. If you have a list, but some of the items are repeated, so maybe you have a list of n items with n repeated can be rearranged in n factorial over m factorial ways. So in my previous example, I had, what I got? 4 letters, and then we had A is repeated, as an example. Now, what about if you had more than just the letter A repeated? So I'll give you another example here. So say you had a word like coffee, what's it? C-O-F-F-E-E. So you can see here, when you want to rearrange the letters, if you swap these F's here, you can't actually tell a difference. And if you swap the E's here, also you can't tell a difference. So 1, 2, 3, 4, 5, 6. So it's 6 factorial over, what would you say it might be? 2 factorial, 2 factorial. The first one for the F and the second one for the E then. It's the 4 in total. For the denominator, yeah. So 6 factorial divided by 4. Yeah. Can someone type, what's a 6 factorial divided by 4? 24. It's a pretty big number, actually. 180. There's actually 180 ways to rearrange the letters in the word coffee then. And it would have been much more if the letters were different. Yeah. 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 I'll get to that example in a moment. You mean if 2 letters have to stick together? Yeah, we'll get to that in a moment. Step by step. Okay, I'll give you just a little one to try. Can I scroll down? So I want to know how many ways can you rearrange the letters in the word happy then, as an example. So try that one then with the calculator. What? 60, is it? So on the top you had 5 factorial over 2 factorial. Okay. So in all these examples, you weren't allowed to reuse the letters. So you couldn't rewrite this word as the letter H 5 times. So the next example we'll have a look at is when you can reuse the letters. So can I scroll down? Yeah. So for example, let's say we have a bag. Let's say there's red, yellow, green, blue. There's 4 different coloured balls in it, and we take them one out at a time. But when we take one out, we can put it back in again. So in total, you take out 2. So you remove, or you take 2, not remove 2. Take 2 then. So I want to think about all the possibilities I could have here. So let's have a look at the sample space. So when I pull out the first colour, how many choices do I get? 4. And the second one? 4, because I put it back in afterwards. So I should have a possibility of 16 here. Okay? So let's write them out. So you can have red and then get red again, red and yellow, red and green, red and blue. Yeah? Then you can get blue for your first one and red, blue and yellow, blue and green, blue and blue, and then green and red, green and yellow, green and green, green and blue, and then lastly, what am I on left? Yellow, red, yellow, 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 green, and yellow, blue. And this one here is a permutation because you care about which you got first and which you got second. So there's 16 possibilities here. So sometimes it's good to think of these problems as like boxes. And you multiply through your possibilities. So if I was to say, okay, well I take 3 out now, how many possibilities do I have? That would be 4 by 4 by 4, which is 64 then, if you could take 3 out. Yeah? You get the idea here? Okay, I'll give you one to try now. Can I scroll down, or do you need a minute? I can scroll down? Yeah. Let's see. Yep, okay. Right, so this one here, I want you to rearrange the letters here, and you can't repeat the letters, so you're not allowed to say this, okay? Just like earlier, can only have one letter used once. My question is, how many ways can you rearrange this if it must end with a vowel? So if the last letter must be a vowel, how many ways can you rearrange this? Yeah? 6 ways, good, yeah. How many choices do you have for the first one here? 3, because you can put or, T, and S here. Okay, and the second one? 2, because you can't use the first one. Next one? 1. So whatever letter you didn't use from or and T and S, you have to use it up there. And the last one? 1. Because I said it must end with a vowel. So the last letter has to be A. Yeah, so what's that coming out as? 6, isn't it? Okay, so it's getting a little bit trickier now. I'll give you another one. Okay. Same deal again. How many ways can you rearrange the letters in the word coffee so that it starts with a vowel? Okay, so think about this one for a minute. I want the number of possible ways you can rearrange the letters in the word coffee so it starts with a vowel. All right, give people a minute, let's see. They're very different answers. Just give people a minute. You got an answer? Ah, it's getting bigger. It's expanding. Is that what you said? Oh no, it's continuing to grow. We better do the answer soon or it'll become too big.
360.
You 360 as well?
Yeah.
Anybody want to do better than 360?
Either 12 or 36.
Either what?
12 or 36.
Quite different numbers.
No, because you either add 360 or multiply.
Most likely multiply.
36.
Not 360? Okay, let's have a look. So, how many spaces have we to fill? 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. So, you couldn't possibly have, I haven't even done anything yet. How many letters can go into the first one? 3. Yeah, you can put in the O, the E, and the E then. Okay, so just for a moment, let's pretend we could distinguish. Okay, so we can put in O. Well, no, maybe we don't have to. We can put in O, E, or E. So there's 3 possibilities that go in there. But then you don't care at all about how the letters arrange themselves there. So how many possibilities is that? 5 factorial. So far we're looking at 3 times 5 factorial. But we have a small little problem because some of those rearrangements, those permutations are the same. So for example, if I put the first E in here or the second E there, I can't tell the difference. Yeah? So I should start dividing now. Just before I do divide, how big is the top? It's probably pretty big, is it?
360.
360. So straight away I know that you're wrong because it's too big now on the top. So we have to start cutting it down. Okay? So divide by 2 factorial, yeah.
It's 2 factorial, 1 factorial, so it's 2.
Yeah, but okay. Yeah, there's also the F that can be repeated as well, yeah. So, oh, I deleted everything. Okay. C, O, F, F, E, E. Okay, so there's possibilities where it could start with O, and then you have your 5 possibilities here. It can start with E, and then you have 5 possibilities here. And then it could start with the other E. Well, yeah, so if it started with O, then if you look at what's here, you have 5 factorial, right? Except you need to divide it by 2 factorial, 2 factorial, because the F's and the E's can be rearranged in this block. What is that, by the way? 5 factorial over 2 factorial, 2 factorial. What is it? What is it? 90.
30.
Okay. 30, thank you. Right. If it starts with E, how many possibilities do you have here? 5 factorial again. Now, just be careful. We definitely can divide by the 2 factorial because we have the 2 F's here. What about the E? Can we still divide by another 2 factorial here? No, I think so, because if there was, say, an E at the end here. Oh no, sorry. Just, yeah. There's only 1 E which is moving around here. Yeah. So it's just 2 factorial. Okay, so what's that then? 60, is it? 90. Did anybody say 90? See, this is hard. Now, what I want to show you, I want to do a, yeah, I'll just show you something here. I'll give you another one while I'm just loading this. So it's the same word again, coffee, except this time I want all the ways you can rearrange the letters in coffee so that the 2 F's are always together. So all the possibilities that have F and F together. Yeah.
For this, even if you add 3 plus 5, 3 times 5 factorial over 2 factorial times 2 factorial, you'll get 90.
Oh, you did it in one step. If you say, do it, say it again.
3 times 5 factorial.
That was 90.
2 factorial times 2 factorial is 90. Is that right?
That's the one we did at the beginning. is what I wrote down. Is it 3 times 5 factorial over 2 factorial, 2 factorial? Yeah, I just wanted to break it up to make it a little bit clearer, because you have to be careful with these. You know, it's not always, as you know, perhaps what you think at the start.
Yeah.
Sir, do you still want it to start with a vowel?
No, no, no. Just the only thing I care about are that the two apps are together. Okay, let's have a look here. Yeah, you got that? 120, great. 3 different answers, yeah? Alright, the only thing I care about is the F's must be together. That's all. Can I scroll down? Huh? 6. Alright, let's have a look. 6. Okay. Okay, so it's actually better to imagine that the two F's were one item. Guys, listen. The two F's were stuck together as like one. So you have 1, 2, 3, 4, 5. And you have this card that's like two F's that can move around through it, okay? So, how many possibilities are there if there was just 5? It would be 5 factorial. However, in the rearranging of the 5, you had 2 letter E's, which of course can be swapped and you wouldn't even know about it. So you would have to divide this by 2 factorial. And what's that? 60. Not 120 or 72, but 60 then. Good, okay. You said 6?
Yeah, multiply by 10.
Possibly, yeah. Okay, let's see. Yeah, no, I think you've got the idea. So I'll just, once you write that one down, just switch the computer here. Yeah, can I switch? Switch? Yeah. Can you see?
No.
Yeah, now you can, yeah? Right, so coffee can be arranged a total of 720 ways, but some of the possibilities are the same, which I'm sure you can see. So I wonder, let's see, what was the one I said a moment ago about the answer where we got 90? The one before this one, what did I say we had to do here? Starts with a vowel,
Yeah.
and
E or O.
starts with a vowel, and was that it?
That's it.
Oh, just starts with a vowel.
Yeah.
Okay, so if you look at this list here, let's just see how many there are. There's 720, and we want just the ones that start with a vowel. So all these guys I can cut, right? They all start with C. What? Okay. So let's cut out 120 of them. Delete. Oh, flip it. Okay. What did I say? 120 of them, wasn't it? Yeah. Okay, delete. Right, now, these all start with vowels, don't they? Right, where did they not start with vowels? Still O, still O. Oh, okay.
So it's just 120 per letter, right? And then there's repeating. So
Confuse me. I'm both counting and looking at letters. Whoops, too far. Okay. Delete. Right, I'll start with vowels. Yeah. So this seems like a lot more than it should be, but why have I got so many here?
There's an E repeating.
There's E's and F's that can be swapped without you knowing about it. So some of these are the same. So perhaps a way to see which ones are the same, I'll just have Excel sort them. So we'll do data, sort, A to Z. So by sorting them, I could see which ones are the same. So you see here, like, how many there? There's like 4 here that are all the same, right? Yeah? Okay, so let's cut out 3 of them. Right, how many is the next one? I have to cut out 3? Yeah. How much further have I to go? No, this will take too long. Screw that. Okay. You can trust me. When you start cutting out, you'll only be left with 90 possibilities. Okay? If you are ever bored, I guess this is something you could do in your free time, but you can trust me on that. You're left with 90. Now, the good thing is, in the exam, these questions are never too difficult. So you saw that last example I did there, where the 2 F's are together, or the example before that where I said it starts with a vowel. That actually is a little bit harder than what you need in the exam. So if you could do those ones, then that means you can do anything in the exam. But don't worry if you found those ones hard. In the exam, they kind of usually stick to the examples I did before that, where they might say, here's a bag with 4 colours, and you take the colours out. How many possibilities are there? Okay. So
Would those be section B or section A questions?
they'd be both. Actually, do you know what? They're usually section A, because they're short. So one last interesting example I want to do. Do you all know, or maybe some of you would know this. Oh, yeah, sorry. WPA2? Does anyone know what this is? It's Wi-Fi. Yeah. It was a replacement of, obviously, WPA, or WEP. This WEP wasn't so secure. There is a problem with some routers that use WPA. So here's your little router here. So I think some of you might know this. You have a little button on a router, and it's called like, I can't remember what it's called, but you use it when you want to quickly connect something. So you press this button here, and then on your device you press the same kind of button, and the 2 of them automatically connect. It's something that you might do with printers, you know, if you had a wireless printer. It's like a pairing button, yeah. So you don't need to enter the full password to connect the 2. The problem is that this pairing device, it's convenient to use, but it only uses 8 digits as a password. So in fact, a laptop could connect to your router if it tries to use the pairing feature, because if you think about it, how many passwords does it need to try? 1, 2, 3, 4, 5, 6, 7, 8. So there's, and I should also say the password is a PIN number, so they're only digits. So how many numbers could you have for the first one? 10, 0 to 9, 10, 10, 10, 10, 10, 10, and 10. Okay, but actually it is even a lot less than this. It's worse than that. The last digit, there's only 1 choice for it, and this is because of something called a checksum. It means that the last digit has to be a certain value depending on the previous 7 digits. So you actually have no choice on what the last digit could be. And I'm not joking, there's a really weird security error. If you manage to get the first 4 right, it gives you a little beep. So even if you had the last 3 wrong, you can know if you got the first 4 right. So if you were to try and list out your possibilities, what would you have to do? You would have to first try 10 times 10 times 10 times 10, which is 10 to the power of 4, which is 10,000. But as soon as you got those 4 right, you don't need to keep changing them. So then you move on to these ones. And how many are here? 1,000. 10 times 10 times 10. So that's 1,000. Oh, that's yours, Michelle. Okay. So how long or how many possibilities would it have to try? It would, in the worst case, it would have to try 10,000 here. Now that's the absolute worst case. literally the worst case. It starts at 0000 and it turns out the password was 9999. On average, how long would it take? Would it take 10,000? What would you say is your best guess for how long it would take? It should take about half of this, 5,000, okay? Sometimes it'll be good, sometimes it'll be bad. This is just the worst case. So what's the best case, how long it would take? No, the best case, 1. So on average, it'd be in between the two, which is 5,000. And then how long would it take on average to get this password cracked? 500. So first you try 5,000 and you get a ding, and then you try 500 and you get a ding. So in total you get 5,500. And you can try and pair once per second. So if you can do this once per second, how long would this take? The process would take less than 2 hours, because it's 3,600 seconds in 1 hour. Okay, so, huh?
You said the last digit depends on the other ones.
Yeah, in other words, you have no choice in the last one. It's a function of the previous 3.
So how do you know the last one?
Huh?
How is that? Does that get the last one?
No, you can use the checksum formula to calculate it. It's a known thing, yeah. So this is actually a bit surprising. It'll take less than 2 hours to hack into the router. The only advantage that's offering protection is that for pairing you have to be quite close to it, like within 2 or 3 meters. So it's unlikely your neighbor will hack it, okay? But I'm just trying to highlight some examples here, permutations and combinations. That's way too advanced for the exam. Okay. What's that?
Symbols and letters.
Yeah, but for the... It is, but this one is particularly easy. You can use software, Kali Linux, I think. Will do it. So Kali Linux has a software that lets you try and crack the PIN number for pairing on routers. Once you're connected via the PIN number, you can then ask the router for what the actual WPA2 password is, and it tells it. So,
It takes longer though. It takes 24 hours
for what?
for the thing.
The WP
Yeah, the software.
for the PIN or the WPA?
For the WPA.
24 hours is actually quite good. It depends on the password to begin with, right?
Yeah, but it's around. Yeah, it depends on the password. It can go longer, but
Yeah.
usually the average amount is about 24 hours.
Oh, for the passwords that people actually
Yeah.
use. Yeah, yeah, because a lot of people's passwords are something stupid like
Yeah.
my home Wi-Fi or something like that. Okay, so if you can try these questions for a few minutes, just 5 minutes, and then we'll start with combinations next.
Which one's the exam
Which one?
type? Exam type.
Exam type? I start getting a bit weird towards the end, so I'd say if you could do the first 11, it's good enough for the exam.